Hello everyone, welcome back to our channel. So today we are going to start with the topic, what do all acids and all bases have in common? But before starting the topic, let's see what we have discussed in our previous video. So in our previous video we have discussed about the neutralization reactions. So neutralization reaction is nothing but the reaction between an acid and base to give salt and water. This is called a neutralization reaction. Similarly, we have also seen the reaction between metal oxides with acids and non-metal oxides with bases, whereas these two bases given the same product, that is salt plus water, which is very similar to the neutralization reaction. From this we can conclude that metallic oxides are acidic in nature and metallic oxides are basic in nature and non-metallic oxides are acidic in nature. This is what we have discussed in our previous video. So in today's video we are going to discuss about what do all acids and all bases have in common. In section 2.1 we have seen that all acids have similar chemical properties. Yes, they have similar chemical properties, like for example in the experiment we perform when an acid reacts with metal, it gives us salt and hydrogen gas. If you see each and every acid when reacting with metal, it yields us hydrogen gas and a salt, which is very similar with all type of acids. What leads to this similarity in property? Yes, we have got a question that what leads to this similarity in the properties. Why does all acids when reacted with metal gives us salt and hydrogen gas? Is there any what is behind the story of similarity of acids? Let's look. We saw in activity 2.3 that all the acids generate hydrogen gas on reacting with metals. So hydrogen seems to common to all the acids. Yes, just now we have discussed that all acids when react with a metal yield a salt and hydrogen gas. If you see each and every acid will yield hydrogen gas when reacted with metal. So from this we can conclude that it might be there is some property called hydrogen which is common for acids. From that activity we can derive that you perform this activity with so many metals, different types of metals, different types of acids, the final product will be the corresponding salt and hydrogen gas. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic. Here they gave us an activity. Let's read the activity. Activity 2.8 talks about take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. From the laboratory, we need to collect some solutions such as glucose, alcohol, hydrochloric acid, sulfuric acid. Fix two nails on a cork. Take a cork. A cork looks somewhat like this. Fix two nails over it. Okay. Fix two nails and place the cork in 100 ml beaker. Connect the nails to the two terminals of a 6-volt battery through a bulb and a switch. As shown in figure 2.3, we'll look at it later, but first let's read the activity. Now pour some dilute hydrochloric acid, which is collected from the laboratory, in the beaker and switch on the current. Repeat with this dilute sulfuric acid too. What do you observe? Repeat the experiment separately with glucose and alcohol solutions. Does a bulb glow in all cases? So what does this activity say is that firstly take different solutions like glucose, alcohol, hydrochloric acid and H2SO4. Why only these four solutions is that all the solutions contain hydrogen as their constituents. So that's why we have chosen the solutions having hydrogen in them. Now take a 100 ml beaker, but before that take a cork, insert two iron nails to the cork and connect these two iron nails to the battery, switch and the bulb. Take 100 ml beaker, pour some dilute hydrochloric solution to it and switch on the circuit. Now you can find that the bulb glows. What happens to the bulb? The bulb glows. That's what was asked here. What do you observe when we add dilute hydrochloric acid to it? You could observe that the bulb glows. Repeat the experiment separately with glucose and alcohol solutions. What do you observe now? In place of hydrogen, in place of hydrochloric acid, if we take glucose, glucose has a molecular formula of what? C6H12O6, and alcohol OH. So when you add these two solutions into the beaker and switch on the current, then the bulb doesn't glow. Why does this happen? Let's see. And the question, does the bulb glow in all the cases? No, it doesn't glow in all the cases. It only glows in the case of hydrochloric acid and sulfuric acid. It doesn't glow in glucose and alcohol solutions when the current is switched on. The figure 2.3, acid solution in water conducts electricity. I'm just revising the activity. So this activity tells us that what do all acids have in common, that is hydrogen, to check whether all the acids, all the compounds containing hydrogen are acidic or not. To check this, we are performing this activity. So in this we have taken 4 solutions where they are kept in a circuit, like pouring into a beaker, setting up an electric current, setting up a circuit, switching on a circuit, and if the bulb glows, then you could say that yes, yes, it has some ions, but let's see what is behind this. The conclusion for this experiment is given here. The bulb will start glowing in case of acids as shown in figure 2.3, but you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the acidic solution by ions. So, in acidic solutions, we have ions. In acidic solutions, like what are the examples that we have chosen to perform this activity? The examples are like, we have chosen hydrochloric acid, we have chosen dilute sulfuric acid, H2SO4. H2SO4 is usually acidic, it's a strong acid, so we'll choose dilute hydrochloric acid and dilute sulfuric acid for our activities. Later we have chosen alcohol and also glucose, H12O6. Now in this, if you observe, the bulb glows only in the case of HCl and H2SO4, and the bulb doesn't glow in OH and C6H12O6 ion. So from this you can conclude that HCl and H2SO4 are acidic solutions. Why doesn't the bulb glow is that, we know that electric current is nothing but the flow of charges. So for the presence of charge, we need ions. So from HCl and H2SO4 we have ions, that is we have cations and anions. But from alcohol and C6H12O6 we doesn't have any ions. Now look at it. Over here in HCl we have H plus and Cl minus ions, and in H2SO4 we have SO4 2 minus and 2H plus ions. Whereas in OH it doesn't dissociate into ions, and C6H12O6 also doesn't dissociate into ions. This states that as the current passes only through the ions, whereas OH, alcohol and glucose, doesn't dissociate into ions, where it cannot transport the ions, where there is no glow of bulb, we could say that there is no hydrogen produced in alcohol and C6H12O6. Whereas in case of HCl and H2SO4, the H plus ions and Cl minus ions carry the charge towards the battery and makes the bulb to glow. Let's study the remaining text. Acids contain H plus ions as cation and anions such as Cl minus in HCl, which we have already discussed here, NO3 minus in HNO3, SO4 2 minus in H2SO4, and CH3COO minus in CH3COOH. Since the cation present in acids is H plus, H plus is cation, Ca plus 2 is a cation, H plus is a cation, OH minus is an anion, Mg plus 2 is a cation, Na plus 2 is a cation, CH3COO minus is an anion. So these are cations and anions together form the ions. Since the cation is present in acids is H+, this suggests that acids produce hydrogen ions H plus aqueous in solution, which are responsible for their acidic properties. So from this activity, we can conclude that H plus ions are responsible for the acidic properties of the acids. Repeat the same activity using alkalis like sodium hydroxide, calcium hydroxide, etc. What can you conclude from the results of the activity? Now we were given the bases sodium hydroxide NaOH and calcium hydroxide CaOH taken twice. Now when we put the solutions into a beaker and switch on the electric current, this dissociates into Na plus and OH minus, whereas CaOH taken twice also dissociate into Ca plus 2 plus OH minus. If you see that we have ions, that means we have cations and anions which are responsible for the electric current, which are responsible for the charge to be carried out. Finally, we can conclude that whenever a base is dissolved in water and made it to dissociate when passed through electric current, it dissociates into the respective ions, whereas in acids they dissociate into H plus and their respective anion, and in bases it dissociates into OH minus and the respective cation. And these ions are responsible for the carrying of the electric charge and makes the bulb glow. So in this also we can conclude that bases also conduct electricity. Bases also conduct electricity. And whereas in bases OH minus are the anions and in acids H plus are the cations. So this is what we have discussed today. So in the next video we are going to discuss what happens to an acid or a base in a water solution. Thank you for watching.